In the first 3 videos of this series, I explained how DCC worked and how the Arduino Uno motor shield R3 was used to implement DCC. In this fourth video, I want to explain the sketch I developed to run an engine on my truck. The aim was, I wanted to understand how DCC controlled engines. I could read the specs, I could play around with DCC++, but it still didn't tell me exactly what was happening on the truck, and in particular what I wanted to know was how the Arduino Uno and motor shield control the truck. I didn't fully understand that, so the only way to work that out for myself was to write an Arduino sketch that did this. So let me explain how my Arduino sketch worked. Basically, I've learned how DCC works now, so it's done the job. So these are the lines of code in my C++ program. On the motor shield, I've got pin 3, which is the PWM channel A. I've labeled pin 3. And 12 here, D12, I've labeled pin 12 for use later in the sketch. Now, the 0 and 1 bits on the truck, if the plus and minus 10 volts in my implementation are 100 microseconds long, this is where the 100 is specified. But if they are, that's for bit 0, so bit 1, it's only 58 microseconds long for the plus 10 volts, another 58 microseconds for the minus 10 volts, and that's where 58 here is specified. Then I needed to define a packet for the train, and I have a packet called train, and the train packet has 3 parts in it. It has an address byte, it has a command byte, and it has an exclusive OR byte, which is the error check. But notice my packet at this stage doesn't have a preamble. I put that in later, and in the initialization of my packet, I put in the address of the engine, which is 11 or 3 in our counting language. The command was 01 to say it's a train speed control, 1 to say the train is to go forward. This 4th bit is not used, and the 4 bits here is to say the train is to move forward at full speed. The last byte is the error check, which I've left at 0 because the error check is calculated later in a sub-function called EOR, which I'll explain later. So this is the initial setup. Now I have to go through the setup part of the program, and the setup part of the program in Arduino are some lines of code that you only run once at the very beginning. Once you've run these, you don't run them again. It's the loop where you keep going over and over again, running the same code repeatedly. So I'll go through what the initial code setup was. The PWMA pin D3, I've already called D3. I'm specifying that as an output pin. That is, it's going to receive outputs from the Arduino Uno. Pin 12 is also an output pin, which is getting its signal from the Arduino Uno. Initially, I'm setting pin 3 to high. Remember, if pin 3 is high, PWM channel A is high, then the output from the A channel is always at its maximum in my setup, which is either plus 10 volts or minus 10 volts. And the direction bit, D12, initially I'm setting to low, but I'll vary this through the program. Next I calculate the exclusive OR for the 3rd byte. I'll explain how EOR subfunction works later, but this takes as input the train's address and command bytes and works out what the exclusive OR value is for it. And then I send out 100 idle packets. Remember, between every command packet, I need to of at least a 5 millisecond delay, and I can do that by sending out 2 idle packets. At the start of my program, when it all warms up, I choose to send out 100 idle packets. It could be 50, it could be 10, it could be 200. It's just a value I made up just to warm everything up. So that's the initial setup. Next I go through the loop, and the loop reads the packet train and keeps repeating train with the preamble in it, which I'll add later. It sends that out on the track in digital form. Then it sends out 2 idle packets to give it a greater than 5 millisecond delay, and then it goes back repeating, sending a command packet, 5 millisecond delay, command packet, and so on. So that's the loop. Now I need to explain these sub-functions, EOR, idle packet, and go straight. Exclusive OR. In C++, there's a command which works out exclusive OR. It's the hat command. So from bits I equals 0 to 7, 8 bits in total, train.eor bit 0 is train.address bit 0, exclusive OR train command bit 0. And I do this through each of the bits, and this calculates the value for the error check at the end and insert it into the packet. Now I need to actually put zeros and ones onto the track. And what I do is, initially when I set up the program, I put pin 12 at low, but now I'm setting pin 12 to high. That is maximum. So this sends out a plus 10 volts onto the track. Depending on if it's a 0 or a 1, I leave it at high for either 100 or 58 microseconds. Then I change it to low. Then I leave it at low either for 100 or 58 microseconds, again depending if it's a 0 or 1, before returning it. So this is how I send out bits 0 and 1 onto the track by commanding bit 12 to be either high or low for the duration 100 or 58 microseconds. Now the next subfunction was the go straight. The go straight tells the decoder what it wants the engine to do from the train packet. First of all, I send out 12 ones for the preamble. Then I send out a bit 0 to tell the decoder the preamble is finished and next is coming the address byte. Then I send out the 8 bits of the train address in here, and then I send out a 0 bit to tell the decoder that I've stopped sending out the train address, and the next field after this is the command field. Now I send out the command field. I send out the 8 bits of the train.command byte, and I go with each of the bits in turn, sending the output bit 0 or 1 depending on the output of the train.command byte, whether there are zeros or ones to transmit. Then between the command byte and the error detection byte, I'm sending a bit 0. Then I send the error detection byte and so on. So this is pretty simple, and this is a mark. This bracket here is marking the end of the go straight function. So I'm sending out the preamble, then I'm sending out the address of the train, and sending out the command I want the train to do, then I'm sending out the EOR, and that's the end of the go straight function. Now I want to define the idle packet. Idle packet is a standard format. Okay, I'm sending out 12 bits in a preamble, which is the same for it's an idle packet or command packet. Then I send out a 0 between the preamble and the address byte, and the address byte in the idle packet always contains ones, it's 8 ones, then the 0 bit. Then I'm sending out the command byte, which in the idle packet is always 8 zeros. Then the 0 bit between the command byte and the EOR. Then I send out 8 ones for the EOR function. The 8 ones is the correct value, but I just sent out 8 ones automatically here. Then I've transmitted a 1 bit to say that's the end of the packet, and the DCC decoder on the train knows I've sent out all the information. You can start looking for idle packet. Okay, so that's part 5. That was part 4. That's how we implemented DCC in code. You can run it yourself quite easily. If you want to change the value of the speed, or you want it to go forward, you change the data in the address.command byte to forward or backwards or change speeds. But it's very simple, but it does work. It shows you exactly how DCC, how Arduino controls model engines on the track using the DCC spec. The next video, part 5, I'll explain the difference between DCC and pulse width modulation. I've finished the DCC part here. I've explained in video 3 how the motor shield is used for DCC, but I want to explain how it's used for pulse width modulation, to explain the differences in case you ever need it.